have decided that in today's class, I must discuss about the test of significance and specifically the way by which the conclusion is drawn after testing a particular hypothesis based upon a system. Test of significance, as you can see, that it is a statistical test which specifies a simple null hypothesis, the size of the critical region alpha, and a composite alternative hypothesis is called a test of significance. Okay, it has already been decided. But you see here it is written, as I said in my last class, that there are two types of test. One is called the two-tailed test and another is called the one-tailed test. Now, two-tailed test, the fate of the test will be decided by the structure of the alternative hypothesis. Null hypothesis will always contain equality sign. Alternative hypothesis can contain inequality or inequality signs or not equal to sign. So if we consider the null hypothesis in the alternative hypothesis section that some parameter theta is not equal to its specific value theta naught, that means two options are open over here. One is that either if theta is not equal to theta naught, that means here theta is either less than theta naught or theta is greater than theta naught. We are not sure about it, and therefore this particular hypothesis, this particular statement written in alternative hypothesis is called two-sided alternative. And based upon that, if I combine this two-sided alternative with the null hypothesis, then such a test is called two-tailed test. Now, in some other problem, if we consider that no, we are sure if null hypothesis is not true, we are sure that either it is less than that or it is greater than that. Suppose my null hypothesis is theta is equal to theta naught. But if it is not true, then we know that then either theta can theta naught. This is, I'm sure about that. If it is not true, then theta is less than theta naught. Or if it is not true, then theta is greater than theta naught. If I can write this theta less than theta naught or theta greater than theta naught, any of these two in the alternative hypothesis specifically, such an alternative hypothesis is called one-sided alternative hypothesis. And when we combine one-sided alternative hypothesis with the null hypothesis, such a test is called one-tailed test. So here here they have considered a specific problem where in place of theta they have considered mu. Mu is the population mean. Okay, what is theta? Theta is actually the generalization of the statistical parameters corresponding to the population. This theta can be population variance, this theta can be population mean, this theta can be population mean deviation, anything. So in general, we term it as theta, but specifically they have considered for the sake of the example, they have considered theta to be population mean. So if in general theta specific value is theta naught, then mu specific value will be mu naught. So here they have considered a two-sided alternative mu naught equals to mu naught. And the chapter which I'm sharing with you right now, the previous to that chapter, there is another chapter which is called hypothesis testing. You can get it from book. There is mentioned one technique which is called likelihood ratio technique, which leads to this sort of inequality, that modulus of x bar minus mu naught is greater than or equal to z alpha by 2 dot sigma by root n. And in my last class, I showed you this particular picture in a very, very crude form, that this is the thing, this is the acceptance region and this is the rejection region. Rejection, there are, for two-sided alternative, there are two rejection regions. One is on the left-hand side of this quantity and another is the right-hand side of this quantity. So if you have this book is in front of you or the page is in front of you, when I shall be referring to the, I'm going to share the stopping the share of this particular page, and I'm going to the whiteboard section where I shall be doing some sort of mathematics to show you how these values mu 0 minus z alpha by 2 sigma by root n and how this mu 0 plus z alpha by 2 sigma by root n are being obtained. So if you have this book in front of you, then you can refer to my whiteboard as well as this page together, and you can understand this in a better way. If you do not have the page in front of you, then okay, no problem. I am coming to this part. I shall be sharing the page once again with you. But you can quickly draw the picture that this is the normal curve and these are the two pillars. These are the two boundaries where one boundary is set at this quantity and another boundary is set at this quantity. And this is the mean part. It is called mu0. So if my the value of the test statistic fall on the left hand side of this, or you can say that the shaded portion here or the shaded portion there, then we are going to reject our null hypothesis, because these regions are rejection region. So they have got some sort of inequalities. There's some sort of limits between which x bar is going to lie. So I'm going to show you this mathematics, and I'm also going to tell you what is z alpha by 2 and what is z alpha. What is the difference between the two? Okay, that thing hasn't been discussed yesterday properly. Just a minute, let me save the chat first of all, because it counts your attendance. Okay, now let us stop the share and let me go to the whiteboard. This is the first time in statistics class I am sharing a whiteboard with you. Now probably you are able to see my whiteboard. So you see that when we talk about a real number, and suppose we have a real variable, say x, and we say that mod of x is less than a, this thing implies that, this particular thing implies that x is either greater than a or x is less than minus a. These are the two possibilities. Okay, so if mod x, modulus of x is greater than a, this implies that either x is greater than small a or x is less than minus a. Now in place of mod x here, we have this quantity x bar minus mu naught greater than or equal to z alpha by 2, as it is given in the book, z alpha by 2 sigma by root n. This was the thing which was given in the book. Okay, sigma by root n. Now you can apply this particular theory of normal real number to this particular quantity. Okay, so what will I get? This implies I'm comparing this section with this one. So if I apply this real number inequality theory to this particular problem, what will I get? Let us analyze. We shall get that x bar minus mu naught is greater than or equal to z alpha by 2, is greater than or equal to z alpha by 2 into sigma by root n, or x bar minus mu naught less than or equal to minus z alpha, z alpha by 2 sigma by root n. By applying this theory, I have got this. Now this implies that you keep x bar on one side, on the left hand side, and you can take all the other quantities on the right hand side. So what will I get? We shall get x bar greater than or equal to mu 0 plus z alpha by 2 sigma by root n. This is one thing. Or x bar less than or equal to mu 0 minus Z alpha by 2 sigma by root n. What does it mean actually? What have I found? I have found two things. One is that we have got a quantity like mu0 plus Z alpha by 2 sigma by root n on where x bar is exceeding this quantity, or either is equal to that quantity or exceeding it, or x bar is lesser than the quantity mu0 minus Z alpha by 2 sigma by root n. We are actually trying to find we are actually trying to find the rejection region. That means if I draw the normal curve, then we are going to find when we are going to reject our null hypothesis. So I'm going to the next page and I'm trying to draw the normal curve over there. So actually I'm getting a normal curve like this. Just a minute. This is the x-axis and I'm getting a normal curve like this. It somewhere looks like a normal curve because it is very difficult to draw I'm using my finger to write these things. So it is very difficult. I beg pardon for this. So this is the mean part, mu0, and I'm getting a quantity like this over here. So I'm getting mu0 minus Z alpha by 2, mu0 minus Z alpha by 2, sorry, just a minute. Bear with me because it is very difficult to write over here in this manner. So mu0 minus Z alpha by 2 sigma by root n. Suppose this is that point, and at equal distance on the right hand side, I'm writing mu0 plus Z alpha by 2, sorry, mu0 plus Z alpha by 2 sigma by root n. So these are the two parts. This is the left hand side of mu0 and this is the right hand side of mu0. Okay. Now where does this x bar come from and where does it lie actually? X bar is the estimate of mu0. Okay, so we do not know the population mean is assumed. Mu0 is one of the assumed value of the population mean. Mu0's estimate is equal to x bar actually. Okay, so suppose x bar may lie here. At this point you can get your x bar at some distance from mu0, and or you may get your x bar here, or you may get your x bar here like this. So x bar will not be exactly equal to the population mean, it will be the estimate of that. So if x bar, we know that x bar is different from mu0, and if x bar is at these points as I have marked, or you can mark a point here also, if x bar lies in this particular region, then it is all right. It is called the acceptance region. X bar is falling within these two limits, and then we can accept our null hypothesis. But if x bar lies in these particular regions, if x bar is less than this, as has been mentioned over here, if x bar is less than this quantity, or x bar is greater than this quantity, in both these cases, we will say that the null hypothesis will be rejected. So here we have actually calculated the likelihood ratio technique has given you the rejection region on the basis of which you are going to reject your null hypothesis. Okay, that particular calculation hasn't been clarified in my last class. So actually I'm showing you this particular technique. I am going back to my previous sharing, that is the PDF file which I was sharing with you, and let us proceed with further, and let me also discuss what p-value is. Okay, so I'm stopping this share and let's go back to this particular portion. Now hope you can see the PDF file. So we have seen that when x bar is less than this quantity, it is called, it is rejected, or x bar is greater than this quantity, it is rejected. Okay. Now you see what is written over here. in figure 1, the null hypothesis mu is equal to mu 0 is rejected if capital X bar is the random variable uh, whose different values are small x bars at different points of time. So capital X bar is the mother variable. So if capital X bar takes on a value falling in either tail of its sampling distribution, symbolically this critical region means the shaded region set over here. These critical regions are called are denoted by alpha by 2, and it is written at if x bar is less than this, we call that z is less than or equal to minus z alpha by 2, and this is termed as plus z alpha by 2, we call it as z greater than or equal to z alpha by 2. So if suppose alpha is 0.05, so what does it mean? 0.05 means that 5% chance that you are actually prone to making the type 1 error. But what is the opposite of 5%? It is 95. Well, 100 minus 5 is 95. So if 5% is the chance of error, you are 95% confident that your thing will be accepted. Your confidence limit is 95%. Similarly, if you consider 1% as your probability of making type 1 error, then the corresponding confidence limit will be 99%. So if alpha is 5%, suppose alpha is 5%, then they have written here alpha by 2 and alpha by 2. Think about the normal curve, standard normal curve, and think about the technicalities which we discussed in the normal distribution. If alpha is 5%, so alpha by 2 means, if alpha is 0.05, alpha by 2 means 0.025. So this portion will be 0.025 and that portion will be 0.025. Okay, so 0.025 plus 0.025 together will give you 0.05. Okay, because this portion, the area of this part and area of this part are similar, we can add them together. So total of this shaded region will give you the 5% chance of making the type 1 error while testing the hypothesis. And this is the 95% confidence limit. This is called the 95% confidence limit, and just opposite to the 5% error. Similarly, you can consider the 99%. You can consider the 99% confidence limit as well. If you are considering 99% confidence limit and your alpha becomes 1%, that is 0.01. And if alpha becomes 0.01, then this portion will be 0.005 and this portion will be 0.005. Alpha by 2 plus alpha by 2 will give you the 1% chance. Okay, 0.01 actually. So this is the thing why we call it as Z alpha by 2 and Z alpha by 2. And we shall consider alpha by 2, Z alpha by 2 when we are subjected to two-tailed test. Scenario will change for one-tailed test, remember. Okay, so I hope you have understood this portion. Let us now proceed with further. And you see here they have mentioned that if we consider the one-tail test, what will happen? In one-tail test, we actually consider either this part or the left-hand side part. So this shaded portion, only this particular right-hand side shaded portion have been shown for mu greater than mu 0, and similarly a left-hand side shaded portion has been shown over here for mu less than mu 0. But see carefully that in both the cases, they have considered the normal curve and the Z alpha by 2 hasn't been considered. Z alpha has been considered. Why is it so? Let us discuss. So if alpha is 0.05, then this entire region for less than type of one-tail test of less than type, this entire white shaded portion, white region is the 95%. And this portion becomes your 5%. So 95 plus 5 gives you 100. And a similar thing happens when similar thing happens when we consider the one-tail test for of greater than type. So in that case, let me show you the page first of all, because this cursor movement is so sensitive that if I do it if I don't do it carefully, then this happens. So when the hypothesis, alternative hypothesis is of one-sided and it is containing the greater than side, then what happens? We get a shaded portion on the right hand side. This shaded portion is only considered. So this portion becomes itself the 5% or 1%, and this white portion becomes your 95% or 99%. So we add them together, we get this 100%. It's total probability. Okay. So this thing has been mentioned. So in my previous class, I sometimes considered Z alpha by 2 when we considered the two-tailed test, and in this another problem we considered Z alpha when we considered one-tailed test. That is the reason why we considered two-tailed and one-tailed. Okay. Let us now come to this particular portion which is called p-value. What is p-value? Let us define p-value from here. Corresponding to an observed value of a test statistic, the p-value is the lowest level of significance at which the null hypothesis could have been rejected. Now the p-value gives you a kind of level of significance. Below, if your level of significance, if you consider your level of significance below that particular value, suppose p-value is certain kind of value, you are fixing a level of significance at something, and that is your p-value. Now, if we consider the p-values lesser than, if we consider the level of significance lesser than those p-values, then your null hypothesis will not be rejected. But if we consider the level of significance greater than that p-values, your null hypothesis will be rejected. I'm again saying, p-value is a kind of level of significance. Okay, p-value is level of significance is a probability of conducting the type 1 error. Now, probability values can be anything. Okay, probabilities value can be P1, P2, P3, P4, anything. Now, you are fixing a probability, say Pi, and you are marking this particular Pi to be p-value. This p-value gives you a limit. Now, it means that if you set your level of significance less for that particular problem, because p-values keeps on changing from problem to problem. So if you are fixing your p-value at certain point for a particular problem, and then what happens that for that particular problem, if you take your level of significance lesser than that p-value, your null hypothesis will not be rejected. But if you consider your level of significance greater than that p-value for the problem, your null hypothesis will be rejected. Okay, so this can be understood if we consider a problem. So let us go to the problem which we discussed in my last class, test concerning means, and let us try to understand what does it mean. Okay, to calculate the p-value, here they have not considered the p-value, but they have said that the p-value of this, what is written over here, had we used the alternative approach described in section 1, that means this section, we would have obtained a p-value. See exercise 21. So if you go to the exercise of this particular chapter, you will see that the same problem is written over here, and they have asked you to calculate the p-value for the problem. Okay, I am going to show you how to calculate this p-value. Now, let us consider this value 2.84. 2.84, this particular value has already been calculated. Now you see, just a minute. Now you see, what was the definition of p-value? Okay, let me write it in here only. So the definition of p-value is 2 probability of, I am going to the whiteboard. Otherwise, I cannot show you this properly. So you mark this particular problem. You have done this particular problem in the previous class. So I shall be considering this particular value over there. Okay, so you note down this value 2.84. So let us stop this particular share and let us go back to the whiteboard. So this is the whiteboard, and you see, yeah. So the definition of p-value is this. The p-value is defined as, this. P-value is equal to twice, probability of mod of z greater than or equal to mod of z greater than or equal to small x. Okay, this is the definition of p-value, and it can be written in following forms also. Just think about the normal curve. You can write it as twice p of probability of z greater than or equal to x, z greater than or equal to x, or probability twice probability of, these are the formula actually, formula for p-value, twice probability of z less than or equal to small x. Now for the given problem, what you have got, your small x means the specific value of the test statistic. Your small x is 2.84. Your small x is 2.84, and 2.84 is a positive value. Okay, if you are not considering, if the value is not coming out as positive, then you have to take its absolute sign. You can consider this or this. Okay, so since 2.84 is the positive value, then in this particular case what will happen, that we are going to calculate the p-value for the given problem. So it will be twice p of z greater than or equal to 2.84. Now you have to take the help of the normal distribution chart, and you have to find this particular probability. This particular probability can be found from the normal distribution chart. So let us find the probability from there. Okay, I'm stopping this share and I'm going to another particular page which will be shared today with you in the Google Classroom. This is the chart I'm talking about. This is the chart. You see what is written over here. In this particular chart, what is written? Just a minute. Just a minute. Where does it go? Just a minute. Very difficult to calculate things using Google, this Zoom, because it's very, nobody could tell me how to conduct a mathematics class wonderfully through Zoom. Nobody has the slightest idea about this, because it is not possible to conduct mathematics class through Zoom, through online. Lots of board works are there, and I have attended so many seminars, but nobody could tell me. Anyways, see, this is the standard normal probability, and what it is written here. This standard normal probability is giving you probability of this kind, P of z less than or equal to x. Now, what is your value? What is your value of x? Your value of x is 2.84. So you see here, several values of x are given, from starting from 0.0 to 2.2, etc. So we'll go to 2.8, the portion 2.8. And we actually want 2.84. So for this, we need to consider the columns. So 0.04 is there. So 2.8 plus 0.04 gives you 2.84. Let us find out the value corresponding to this value, 2.84. And this is the value, 0.9977. This is the value corresponding to 2.84. So what I need to do is that I need to, from the chart, I have got my value. So, but remember, the chart was of probability of z less than or equal to x. The chart was meant for probability that capital Z is less than or equal to x. And here we got probability that capital Z is greater than or equal to x. So you need to do a short calculation over here. So you write 2 into 1 minus probability of Z less than or equal to 2.84. 2.84. And if you calculate this, if you put the probability which we have got over there, you will get the value 0.0046. This means the level of significance, if we consider the level of significance lesser than that, your null hypothesis won't be rejected. But if we consider the level of significance greater than that, your null hypothesis will be rejected. In that problem, we considered the level of significance to be 0.01, and 0.01 was the value which was greater than this. And therefore, in that particular problem, we rejected our null hypothesis. We have less than 1 minute. If you have not understood, then you can rejoin. I shall be there to clarify your doubts further. Okay, so the time is actually running out, so you can rejoin. I shall rejoin. You can rejoin to clarify. If this section is not clear to you, you can rejoin and you can ask me.